Experiment is the role of gravity in flatworm regeneration.
Good afternoon, everybody. How you guys doing? Awesome. Okay, so my name is Appiah. I'm the co-investigator of this project experiment, and
I'm Matthew Vuong. I'm the principal investigator. This is our project, The Influence of Microgravity in the Regeneration of Planarian. Our other three members, Richard Gomez, Isaiah Ogunmakin, and Bassam Razak couldn't make it out here, but our teacher facilitator, Michael Bowling, did come out here with the 18-hour drive from Houston. But let's just get into it. Our entire project revolves around this worm. This is a Planarian. It's a type of flatworm with some seriously impressive regenerative capabilities. If I were to cut this one worm in half, that both the tail piece and the head piece would grow respective heads and tails, and that one worm would then become two. And how they do this, though, is through neoblasts, which are comparable to human stem cells. Essentially, these neoblasts are able to specialize, which allows them to create more tissue, if that makes sense. And these neoblasts, they come together and they form a blastoma, which is kind of like a base from which any tissue or organ will grow from.
that all boils down to the question, how does gravity affect the regeneration of the Planarian species that we're using, which is Jagesia dortocephala, which is a mouthful. Our proposal is, we believe that since Planarians share the same physiological and cellular structures as humans, we could apply their use of neoblasts, blastomas, and stem cells to also human life. So if we see how they react in a microgravity environment, we can then apply that to ourselves in space. So we're going to be using a type 3 FME, which is 3 compartments, 2 clamps. One compartment will hold a whole worm, which is our control, and the second compartment, which is the middle one, that's going to hold our split worm, Kenny. Well, we respectively named him Kenny 1 and Kenny 2 since he's going to be chopped in half. And then in the third one, that will be the fixative that's going to kill the worm and then preserve the body. So what we expect is that two weeks up in space, the 2 worms will fully grow and they'll be fully Kenny 1 and fully Kenny 2. We're going to release the fixatives, then sadly kill Kenny 1 and 2, but then preserve Kenny 1 and 2 so that when they come back to Earth, we'll be able to compare their body parts and look for stuff like pigmentation, because since when they're regenerating, the pigmentation usually get pretty light, and also see if any length has changed.
Okay, so in this diagram, you could see this one worm was cut transversely twice. So in the first, they cut off the head, and they cut off the tail, which left the middle piece. So then this follows the regeneration pattern of the middle piece solely. So from the day 0, it's just the middle piece, but then as the days continue, you'll notice more white pigmented skin growing, and that's essentially the worm that was growing. So if you think about it, this one middle piece, it didn't have a head or a tail, but it was able to grow another one. That means eyes, that means everything. Pretty impressive. But how we can use this, first of all, is 1, it'll give us some further understanding of how to use stem cells in living tissue. But 2, in the future when we go to space and we either pioneer or we're going to open it up commercially, we'll be able to understand how cell regrowth works in a microgravity environment, which could be very important because, what if you lose an arm in space? We want to give a shout out to Junji Murakama and Michael Levin from Tufts University. They really helped us out with the foundation for this project. Of these. Aside from that, questions? No, question?
How are you going to get the worm?
Okay, so we ordered the worms online from Carolina.com. Yeah, that's like a science-based site for students and facilitators. And we just ordered those worms and they shipped to us, and we've been cultivating them for a couple months.
So are the astronauts going to remove Kenny and cut him in space, or?
No. All right. So we cut Kenny a couple days ago, and it's about to be launched up. But Kenny's already cut, All we need is the astronauts to release a fixative, or release the clamp, which will release a fixative that will preserve Kenny. It's a good question. So how we ensure that the worm doesn't start cellular fission before it reaches microgravity is we have the worms refrigerated in a specific temperature that keeps them from fissioning before they reach microgravity.
How big are these worms?
Now it's my turn to take some of the spotlight. So your question is how big these worms usually are. Well, they could be really small. I don't know if you can see this, but you know the tip of my nail, obviously, you can pretty much see that. They could be that small, or they can grow up to a seeable size, which is usually 2.5 centimeters.
So if they're at that seeable size, then how exactly do you cut them?
Yeah, that was a problem that we had. We were looking for microscopes that were powerful enough where we could see the whole body and be able to make the precise cut through the middle. And Kenny was a tough one. That man was running around left and right. It was pretty hard to, get him straight down the middle. Yeah. Oh, last answer.
Real quick, how many Kennys were there?
How many Kennys? Well, initially there was, when we asked for volunteers, everyone spread apart. Kenny was the only one. We just picked him out and then, yeah. So there was one Kenny. Hopefully there'll be 2 Kennys by the end of the experiment.
What food will be available to meet their energy needs for this regeneration?
Okay, so we had to factor that in. That was actually very important, but we learned that these Planarian, they have an ability to decrease their mass in order to make up for a lack of nutrients. So they're able to decrease proportionality in order to make sure that they stay alive. And because of that, they're able to stay alive for maybe like a month or so without food, which is, again, pretty impressive.
What's your ground-based experiment look like? What's your ground-based experiment look like?
Basically parallel to the one in space. So we're going to, the difference is that one's in microgravity and one's in Earth's gravity, so we're going to see how gravity affects the regeneration. Any other questions?
What did you name the worms on the ground?
Oh, well, actually we named one Jimmy, and then we had Neutron, and then we had Sponge, and then we had Bob. We had Quavo, if anyone gets the reference. What else did we have? Oh yeah, Timmy and Turner. Yeah, we had him too. Yeah. Any other questions? Well, the whole worm is to see if he's our constant. It's to see if anything goes wrong with the experiment besides the ones we have accounted for. So if the whole worm dies, then we made a uh-oh in our experiment. Alright, and why did Mars turn red? Yeah, that's actually a pretty good one. I really don't know. Sorry.
I got a question. What is the function of a flatworm on the Earth?
So these flatworms, they're actually a lot more common than you think. They're in any rivers or freshwater lakes or anything like that. You just can't see them. They're under rocks. And the function for them is basically they're a type of flatworm. They live for themselves. They just sort of help with the ecology of small lakes and ponds and stuff like that. They're really basic, but they really do make a big impact.
When the worms go up to space, how do they come back?
Excuse me?
How do the worms come back?
Okay, so the worms are going to come back, same as all the other projects. It's going to come down in the shuttle, and essentially we're going to get that, by that time it comes down, the worms are already going to be preserved in the fixative, which means that no regeneration should have happened in Earth's gravity. It'll just be shipped back to us, unless we want to drive another 18 hours here from yet. Or any other questions?
This young gentleman was talking about finding the spotlight, getting more time in the spotlight. I have a feeling the spotlight's going to find him a lot over his lifetime.
So that concludes the student presentations.